In this video, we're going to be introducing logistic regression, which is another modeling option we have if the response variable of interest is a binary variable. So we've talked about doing regression where our response variable is a numeric variable that has some scale, and we're trying to kind of predict the value of a response variable for an observation given some other predictor information. So now we're going to talk about what if that response variable is actually binary, meaning that there is just two different outcomes of interest. So that's really common to look at when we're doing, say, medical examples, because we might be looking at trying to model the likelihood that somebody has a disease or doesn't have a disease, or that somebody will die or not die from a particular condition. And we could use something like logistic regression to kind of make a prediction for that risk and for that ultimate outcome for an individual. So with just like with linear regression, we use the term simple, as in simple logistic regression or simple linear regression, to talk about a model where we only have one predictor used, and we're just looking at how that information from that one predictor helps us judge the outcome here more appropriately. So a simple logistic regression model looks like this, where we have an intercept term and then a slope term on this predictor variable, and we're using that to model this term over here, which looks very confusing, I'm sure, at first, but we're going to kind of break this down in a little bit. And just some more background, this is what's called a generalized linear model, where our response variable would be zeros and ones, or at least those are the different outcomes that we could see for our response variable. But we're not actually using that as the simple result over here. Instead, we're using some equation of the response and then predicting it with a linear equation over here. So if you were to take more modeling classes, like another linear modeling class like Ch14 or Ch425, you would learn more about generalized linear models and how that, like why we use that term. But for now, just know that there's this thing called generalized linear models, and logistic regression is one example of that, and that we can still write a linear equation of the predictors, but we have some kind of transform function of the response over here on the left side of the equation. And this right over here, this ln stands for the natural log, so the log with base e of, so I'm going to write log base e of the probability of this particular outcome happening, so the probability of one particular of the two outcomes, divided by 1 minus that probability. And we call this, this part right here, the odds equation, because this is the odds of that outcome happening, the probability that it happens divided by the probability that it doesn't. And then by taking the log of it, we call this whole thing the log odds of this outcome. So we'll get to that more coming up as well. All right, so let's kind of break this down with a really simple example so that this makes a little bit more sense what's going on here. Let's say that we're trying to predict someone's biological sex from their height as a predictor variable, right? So if you think about, heights, heights can be somewhat helpful in kind of differentiating biological sex, because biological males are more likely to be taller than biological females. So if I knew someone's height, I could actually use that information to make a judgment about their likelihood of being biologically male versus female. Just like with any model, this is not going to be perfect. Like I can't say with 100% accuracy what someone's sex would be based on their height. But I recognize that for certain heights, the likelihood of being male might be higher than female, and then for other heights, the likelihood of being female might be higher than male, and that might be information that's helpful. I don't know if it's really helpful in this case, but we'll do it because it's simple, and hopefully this makes sense, and this example helps kind of solidify what logistic regression is doing. So in this data set, we have 30 adults, and we recorded their height in inches as well as their biological sex. And so we created a model, and we're kind of bypassing, how do we create a model? How do we find these coefficients? We're not going to worry about that here. We're just going to focus on the interpretation part. So we fit some model using some method to help us determine kind of the best way to identify this relationship between height and biological sex. And so if we look down here at the data, you're going to notice that this 0 right here, I should write this out here. So in this case, 0 is coded for female and 1 is coded for male. It doesn't have to be this way. We could have coded it the other way, and that's totally fine. We get the same equation just going the opposite direction. And one observation that we might see up front is that, as we might expect, the lower heights are more associated with females, and the higher heights are more associated with males. And so this line right here is modeling that likelihood between the two. So given a particular height, the position of this line is representing the likelihood of somebody being, in this case, biologically male, given that that is their height. It never quite reaches 0%, it never quite reaches 100%, but it is kind of hovering between those two, and obviously it kind of is what we would say asymptotically approaching 100% and asymptotically approaching 0% at either extreme of the range. So that means that given a particular height, given this data that I've observed, I can kind of model what I think the likelihood of somebody being biologically male would be given that height value, using this data kind of as my model fitting start for that. All right, so we fit this data, and we used R to do that for us and to produce a model. And we found that this model has an intercept of negative 32.97, and it has a coefficient on height of 0.4880. So that means that if I were to transfer this into the model, I would predict the log odds of somebody being biologically male is represented by this equation, where their height would be plugged in here, and we'd use this to get an estimate of the log odds of that value. So in the next video, we're going to break down a little bit more how this works and how we kind of interpret these coefficients, because it will be a little bit different. One thing that we want to do is rewrite this equation such that we're just left with p on one side as some function of x in the other values that I have here. For now, just this big idea, logistic regression is about predicting a binary outcome using one or more other predictor variables. In this case, with simple logistic regression, we're just using one predictor. So based on the value of this predictor, can we make an estimate for the likelihood of somebody having one particular outcome versus the other?